Everybody hear me pretty well?
Yes.
Nice. I'll go ahead and present. First, I wanted to say thanks for putting everything together. I think it's important to get user groups together like this. We have kind of a similar one every year at NI Week. I know that everybody can't come to NI Week, so I think it's definitely a show that everybody was able to get together and kind of put together content and really build connections in the industry. That's a really important thing, is understanding who else in your area is really an expert, and even if you're not an expert, being able to bump elbows with other people in the industry is a big thing. So first, I wanted to start out with a suggestion that somebody else actually posted, was to kind of represent somebody we think is influential, either recently or a history, Fragment. So I wanted to mention this photo. Probably a lot of you have seen it. If you haven't, this is actually from the Event Horizons project. So this was really the first image of a supermassive black hole. So actually, here's another image that probably went viral. This is Katy Bauman. She's a postgrad at MIT, and she had a pretty good part in creating some of the algorithms they used to actually stitch together that image. And this is a picture of, yeah, if you hadn't seen it already, this is one of the moments where they realized, oh, like this is actually working. So I wanted to mention her as somebody that's had a big influence. I think that other than the obvious contributions towards the Event Horizons project, there's an aspect of publicity here. So this picture went viral. Also, her TED Talk has something like 500,000 views. If you haven't had a chance to check it out, it's really interesting. I'd encourage you to check it out. But that kind of positive publicity, especially with somebody so young, is important, I think, for getting young people involved in STEM. And I think that has a big impact. So just wanted to take a minute to recognize that. So for my content today, I was just going to share some of what's new in TestStand 2019, and then I'm open to feedback and talking some about the roadmap. So here's the overview. I'll actually hit on each of these things, so I won't go too in depth. I do have slides, but I also have a test machine that I can just show you this. So TestStand 2019 released around NI Week of this year. There's one feature in this list that actually isn't totally released yet, and we'll talk about it closer to the end. The first one I'll just speak to, though. So there's actually really nothing to show. So the multi-core scaling improvements is distilled to one bullet on here, but I actually want to talk about it for a minute because it's a significant improvement for the customers that care about it. So this bullet essentially is representative of a bunch of internal performance work that we did in the engine. So this is largely driven by needs from our semiconductor test customers. So think systems that are highly parallel. So like probably a minimum of 4 parallel sites, but up to 36. I've seen different test sockets running in parallel. We noticed that there was some unnecessary overhead coming from the TestStand engine in that, and we put in a lot of work to reduce that overhead. So the people who are going to see the most performance benefits out of this are ones that are highly parallel and shorter test times, because the overhead wasn't, huge, but as a percentage of your overall test time, if you had, say, a 16 site test system and it only took a few seconds to run a test, and you're running hundreds of thousands of tests a day, a 1 or a 2% overhead is significant. You're talking about some major throughput improvements. So yeah, that's really the gist of that improvement. If you don't have really high parallel or shorter test times, you probably won't notice a significant difference in performance from this. If you have a longer running test, like an hour long, the overhead is pretty negligible. But in general, performance benefits are always nice. Also, we noticed that some of the UI controls feel a little snappier. So they're internally, we use a lot of parallelism in the UI controls. So there is some kind of less measurable benefit there, but I personally noticed it. Like when you close out all the execution windows and you have either a lot of execution windows, they seems like they close a lot faster. Just kind of a smaller thing I noticed. Then I'll move on to show some of the other features in a little more detail. So this one is the stream loop. So if you use TestStand 2017, you probably noticed the introduction of this feature called data streams. It's basically the ability to, at least right now, reference a CSV file on disk, and you get more of a reference to a file to use it like a file stream. In 2017, you could iterate over them with a for each loop. The stream loop is like a slightly less manual way of doing that. So it's really just a for each loop that only iterates over input streams. So yeah, the idea here is you have a huge CSV file, or maybe even not so huge CSV file of input parameters you want to sweep over. You reference the data stream as an input record, and then you can optionally choose an output record. So in this example, reading in some parameters, I want basically like a set point and some limits, and then I'm outputting everything to CSV. So yeah, it's just a nice way of kind of externalizing sweep cases and things, right? I don't necessarily want to change my test sequence if I, want to change some of these parameters, or if I have a huge, different variations. This is kind of a nice thing. It's not anything that you couldn't have done in, TestStand 2017 or earlier. This is more just making it more of a first-class citizen, making it a little easier to use. Any questions?
No, I think we're okay.
Also, just to kind of emphasize all the people that have joined online. Obviously, if you would like to ask a question, just unmute yourself, and then you can obviously ask your question.
The last thing I'll mention here is that so right now we do only have CSV as the input stream types, but input streams themselves, it's really just an interface. So it's very possible for NI to create more of these in the future, or if you're somewhat of a power user, I'll say it is possible to create your own. We don't have a ton of examples on doing that yet, but it's something that we might look into in the future. So yeah, right now it's CSV. That seems to be probably the most popular one we've seen, but it really is kind of a generic interface. So anything that's like iterable could probably be made into a data stream's input or output. The next one is really in the same realm. So we're kind of running with the parametric sweeping for this release. Another feature we added was called a sweep loop. So this is another loop type. I kind of refer to this as like a for each loop on steroids. It's similar in concept, but instead of having all of your parameters that you're sweeping over defined in a static file somewhere, this will really allow you to generate them either dynamically at runtime, or pull them from an existing TestStand variable, or pull them from a sweep loop. There's also this new concept of sessions that we'll get into a little later. In general, it works like if you look at the bottom image here, you can see that the plus and minus buttons, you can add pretty much any number of parameters, and then you can, towards the right-hand side of this box, you can see basically where you can pick a strategy to use to calculate basically the permutations you want to do. So in this case, this is a start-stop step. We're doing a logarithmic operation, so that will really generate the parameters for us. You can also, if you look in the middle, you can kind of see some of the different varieties. Some of these are going to be constants. Some of these actually get read from a data stream. There's really a lot that you can do here. There's also that permute checkbox at the top. So this is really just a faster way of doing like nested for loops. So if you check that, it's basically going to hold index 0 constant, run through all the different combinations of the rest of them, go to the next item in index 0, run through all the different combinations. So you very, very quickly will build up a large amount of iterations with this. And again, it's not something that you couldn't have done before in TestStand with just a couple of nested for loops, but it does, I think, increase kind of the readability of your code and definitely the ease of, sitting and editing it. So I think it's a nice performance or usability improvement. Not necessarily a game changer for probably you folks. You've probably done this before in your own ways in TestStand. There's also this nice, at the very kind of bottom, there's that export button, and it will generate this pop-up on the top. So if you wanted to actually export really all of the different permutations from the sweep loop, you can do that. It'll send them to CSV that are actually already formatted in a way such that it should be used with the stream loop. So if you want to do that for documentation, or for some reason you wanted to export those and use it with the stream loop, instead of having this dynamic way of doing it, you can do that. I will say the stream loop probably has like a slightly better performance than the sweep loop. It's probably a really small difference, but since the sweep loop does calculate these expressions at runtime, there's a little bit more overhead for that, as opposed to just churning a file and iterating over everything in the file. You also then lose some of that, ability to actually dynamically calculate these settings at runtime if they change based off, some former variable. The next one is Python adapter. So I'll actually show this one instead. So here's the actual sequence I used to make that GIF. The Python adapter, if you haven't used them already, there's been custom step types out for a little over a year at this point. So they were posted last summer for Python. So we posted custom step types that basically provided the ability to call Python scripts, pass variables to and from it, and specify some settings around your interpreter. They're actually really developed from the same code base as the Python adapter, so they share a lot of the same underlying code. The reason we posted those earlier was to essentially allow people who are using an early version of TestStand, like TestStand 2014, for example, doesn't have a Python adapter. We posted the custom step types so that you didn't necessarily have to upgrade to the newest versions of TestStand to get basic Python support. But 2019 does feature the fully integrated adapter, so you get some of these nice step settings panes. There's a little bit more functionality as far as like integration, but as far as doing like basic calling scripts and passing variables, it's pretty similar. That being said, I think that going forward, most of our investment is going to be towards the adapter. So if we rev the step types, it'll probably be smaller incremental things like supporting new versions or fixing bugs. But if we add a lot more functionality, it's going to be towards the adapter. So yeah, it's similar to the other adapters we have. Obviously, it's not as full featured because it's brand new, but we're going to be working on it kind of over the coming years to add more to it. This has been a really common request kind of across the board from a lot of our customers, is the ability to call Python, whether it be for calling test steps like I've made here. Probably the more common thing I've heard is just being able to call some analysis script or some script that somebody else wrote. Python's kind of wildly popular and growing language. So there's a lot of examples out there. There's also probably a ton of other people in your business or your customers' businesses that are already using it. And if they already have code that you can reuse, that's great. So I'll run this. So I'll mention kind of how I set this up exactly. So I have in process setup, I basically initialize 3 different classes in this Python script. So I'll pull this up. You can see like this one is DC power test cases. I basically pick the Python file Let's see if this works. Yeah, there we go. So here's the actual file I used. I have a bunch of kind of helper functions defined at the top. Made a few classes. So if I come down to this DC power test cases, you can see it's basic. Like I have an init, a delete, and then I have a bunch of methods I'm going to call. So yeah, kind of what you'd expect if I was going to set up a test class here. So I'm initializing those here. I'll probably show a little bit more about why I'm splitting these into 3 classes here in a second. I'm storing a reference to those classes in a file global, and I'm actually doing a little kind of special thing here. Under advanced settings, there's actually a way on a per step setting to specify an interpreter. So I'm actually going to use 3 different interpreters and kind of manually specify which one I want to use in my steps. There's a few different ways you could go about this. So there's the normal adapter settings where I could say on a global level, I just want to use 1 interpreter. You can also spin up per thread or per execution interpreters. I actually want to have control over what steps are running in each interpreter because of what I'm doing here. So this auto scheduled resource block, I'm basically going to use to schedule what interpreter is running what step. That way I basically can get around some of the limitations of Python's global interpreter lock. So I'm using a totally different process to run scripts in parallel. That way, if anything blocks, like fetching data from an instrument, I'm not actually serializing things on the interpreter level. I'm using multiple different interpreters in parallel. So when I run this, you'll kind of see it. Let's see, pull this down. So you can see these are actually running different steps. And if I pull up Instrument Studio, you can actually see here's the instruments that are running. So this is my scope. Just reading back an FGen through a filter. That was pretty quick. And if I come and look in here, you can see some graphs I made in Python. So this one's obviously failed. This was a pretty short script. Like if I come back to this filter test results and look at this, it'll actually bring me to the function. So all I really did was actually use the data stream to iterate over and all my input parameters, so all the different frequencies I wanted to run a test at. I output everything to a different data stream. So this output stream here. And then in Python, all I did was I iterated over that stream, made a nice little graph, saved it off, and put a link in the report. So that's kind of the gist of the Python adapter. Any questions about that?
Can you debug into it? I mean, can you step into it?
So we don't support stepping in right now. That's probably a good question. I can touch on some of the things we don't do yet. This is actually a good topic. So we don't support stepping in. We support stepping over and like breakpoints and things. But we actually stopped at the point of stepping in for at least for now because of some of the variety of editors that folks like to use. So debugging APIs are usually going to be specific to, Python has a low-level debugging API, but if you wanted to use the editor's debugging technology, like this is VS Code that I'm using, it's probably going to have a different debugging API than like PyCharm, for example, or idle, or some of the other like ones that people use. So we didn't necessarily want to yet pick an editor to run with, or have to do work to support a whole bunch of different editors. We didn't really know what folks were using. So I'm curious if among you guys what a choice of editor is if you do use Python.
So for me, it's VS Code. Anyone else?
PyCharm.
Was picking up the ones also. Yeah.
And another colleague of mine uses PyCharm, as he said. But yeah, I think VS Code being open source is a good choice.
So, but you can do breakpoints in the Python code?
No.
Oh, so you can do breakpoints in TestStand. You can also, if your other editor supports attaching, you can do breakpoints in the Python code. there's a little trick to figuring out what interpreter to attach to. So TestStand runs all of this code, in its own interpreter or however you specify it, right? So in my case, I was actually running 3 different interpreters. If I wanted to figure out which one to attach to, it can be a little bit of a pain, right? Because it's not necessarily saying, hey, this is the one that's running this function, right? That's really a big benefit of having that step into, is that at a certain execution, you could step into it. It would open up the right, interpreter context to debug in. So what I've used is actually kind of a helper function in the Python code I want to debug. Is at the very beginning, I'll either have a pop-up that just shows the process ID. It's a one-line thing to just have a message pop up and then print the process ID. You should be able to get it from the system library in Python, and then from there, just go ahead and attach the debugger, and then click OK on the pop-up, and then your test should run just fine. Another thing you could do if you don't, want to use a pop-up, or if a pop-up somehow is like impacting the part of the code you want to debug, in the adapter, we actually have an option to show the console. So for each interpreter, you can pop up a console, and you can just print the process ID, to the screen, and then have a wait or some time that you could use to attach. You also probably want to print some kind of informative info about what console this is, right? Like if I was, in my case, I'd probably in process setup say, hey, this is my DMM interpreter, this is my DC power interpreter, something along those lines. The other thing I wanted to mention was probably the most notable thing that we're missing today in the Python adapter, as opposed to the other adapters, is a full-fledged TestStand API. So like we have LabVIEW and .NET APIs and C APIs for TestStand. We don't have a Python API yet. The TestStand API, we do have a COM API. So there's a number of different ways to call into those from Python. They actually work pretty well. So it'd be just like using our API in another language. But there is a catch here. We don't support actually passing object references, TestStand objects in and out of Python interpreters yet. So that's a thing that we're looking at probably the next release, is the ability to pass in something like sequence context. But today we don't support that. So using the TestStand API in Python is somewhat limited. Like if you do it, you'd basically be at the point of like kicking up a new execution and running a sequence, not so much of on a step level being able to use things like termination monitor or getting at the rest of the context of the sequence without passing in exactly what you want to see. Other than that, we do support most of the basic things you'd expect, like Python objects work, lists and tuples, booleans, numerics, and strings. There's this nice dynamic type that was put in, so it's not dynamic exactly in the sense that you'd expect Python to be, but for TestStand, it does allow you to, instead of having it necessarily being a strictly a static variable, right? Like this string path or the return value, since Python can return basically anything, since it's dynamic, you can actually use an expression to determine what variable it'll be or what type it'll be. So basically these two, whatever type that this expression evaluates to at runtime, say if I were to use locals dot, some expression that picks a different variable, it'll actually, from Python, it'll convert, whatever Python gives you into the output that this expression evaluates to. So kind of a smaller feature, but pretty nice. So any other questions? If not, I'm gonna go ahead and move on, so I don't bump against too much on time.
I think we're okay.
Let's see if I can. Oh no, there we go. Moving along, some of the other things we did in 2018 were broad adapter improvements. So For LabVIEW, we added support for LabVIEW 2019. Interesting note here, this is the first version after 2018. So this is really the first version that we're testing well, we've tested it before, but the first version that general public and customers are testing the full-featured runtime backwards compatibility. So in 2018, LabVIEW introduced the backwards compatible runtime. This is really the first release after that where that's coming into effect. So if you have a binary from LabVIEW 2018, like a PPL or something, it should work in the LabVIEW 2019 runtime engine without you having to recompile your code. So kind of a nifty thing. It's a bit of a follow-on from the last release. We supported LabVIEW 2018 before, but this is also the first release where that feature kind of comes into play. The next thing was auto switch for PPLs. This is another one where it might just be easier to show. In the LabVIEW adapter, there's now an option for basically to always run a VI in a pack project library. This is an adapter level setting. If you drop down a LabVIEW step and specify a project, and that project has a build spec in it, there's basically a way to automatically switch from running that VI as a source VI or as a PPL. There's a lot of benefits to using PPLs, especially for deployment. Kind of one of the downsides is for debugging. It can be a pain, especially when you're doing like iterative development, right? If I, make one or two changes to something, if I'm using PPLs, I have to go switch that step to use source VI, make a change to it, recompile my PPL, and then switch it back. Sometimes the behavior might even change if it's related to application instances and things like that. So this is a feature that really you should just be able to specify the project you're using in LabVIEW with a build spec in there. Any changes you make, there's actually a setting in TestStand to automatically build the PPL when you run it. So yeah, it's a nice feature. You can set up your code basically as you want it deployed, and then if you need to make any changes, it's just a matter of a global switch to switch everything back to source VIs instead of the PPL. So you need to debug it or make edits. I like the feature. We'll see how it goes. For CVI, we added a couple of new things. This one does require CVI 2019. So really the reason for that is that this version of CVI, we actually added some custom metadata into the binaries, and we also added in TestStand features that read that custom metadata to do things like distinguish pointers from a pointer to an array, or the ability to auto create structs and enums from what's defined in the DLL. There's also the ability to specify an out parameter, which is nice too, and then better source code navigation. So some smaller things here, but I think they're reasonably big usability improvements. NXG, we had support for 3.0 at this point, and then some more smaller features. So logging arrays, some better consistency of logging, better integration with the help, and the ability to basically figure out what dependencies are missing from a project and add them in. The next one, so there's actually two listed on this page, but the GIF kind of draws people's attention. We added quick drop. So this is kind of similar to what you'd expect to see a quick drop in TestStand be. It will let you quick drop steps, sequences, step templates, variables, types, things like that. It's a nice improvement, especially if you have like a long list of types. Pretty useful feature. The other one is reporting improvements. So we added a PDF report option to all the default reports. So if you use like an HTML report, there's now just a checkbox for turning on the PDF report, and it'll automatically generate one in addition to the HTML report or the XML report. Because of that, we also replaced the ActiveX graph with an HTML-based graph. So if you use the built-in testing graphs, they should work better with yeah, a PDF report, but also more modern browsers. The kind of last section I want to hit on here are all, they're not necessarily TestStand features, but they're directly related to TestStand in one way or the other. So the first one is Instrument Studio integration. I'll actually just show this one too. So this is the one that I mentioned at the beginning, isn't quite released yet, but I'll talk to it. So Instrument Studio 2019 is what you're seeing here. If you haven't had a chance to use Instrument Studio at all, it's been out for a little over a year. So the initial release was in 2018. It's really just soft front panels for all of our PXI instruments. Well, that's the intent. Right now, it doesn't support all of them. It supports a lot of the core modular instruments, so scopes, DMMs, SMUs, and power supplies, and waveform generators. We don't support RF yet. We don't support DAC yet. Some of the other like less popular modules we don't support yet. But kind of the intent of this is to be the you know, the future kind of environment for NI soft front panels. So instead of having a bunch of different windows for each instrument, you get really one environment where you can set up a multi-instrument view. You can split these out into multiple tabs across multiple screens, and then figure out how you want to lay these things out. Kind of the other big flagship feature that gets a lot of oohs and ahs about Instrument Studio is the automatic debugging. So you probably noticed it when I ran that example earlier. You can actually just see what's going on in the you know, driver session. So if you're running, you know, whether it be TestStand or just a Python, in that case, it was actually Python scripts that were running, calling into the driver. It could also just be LabVIEW or just a C program. Instrument Studio will automatically monitor what the sessions are doing. And if you do hit a breakpoint, you can actually come in and take control of the instrument. So in this case, I gotta create a wonky scope error. Not sure what's going on there. Nah, great. If you take control of the instrument, let's see. There we go. So yeah, I should also mention I'm using a very early build of Instrument Studio. This is a pre-release build, not a final build. So we're probably going to release in the next month or so, but it's not final. So I'm actually using beta drivers and not even a beta version of Instrument Studio 2019. So yeah, if I was using this scope in a LabVIEW, you know, VI, you actually be able to see what the driver is doing. And if I hit a breakpoint in LabVIEW, you should be able to take control of the driver session, make changes to it, and then start rerunning your VI using the same driver session. Since it's really talking to the same underlying driver session, there's only one session here, so any changes you make either place to the instrument config apply both places, and you'll be able to see the changes either place. So kind of building on that instrument configuration, we added the ability to export to TestStand. So in this case, it's only going to export one thing, so I'm only using one. All right, take control of the rest of these, and choose export to TestStand. Oh, I'm gonna run this. Let's see. Actually, there's this new tab in TestStand. Well, not tab. It's a new section in the templates where you get this IO configuration. So what this will be is basically all the instruments that you're using in a panel, whatever configuration they're in. A snapshot will be taken of it, and then in TestStand you can drag this in. This step basically will create a session to all those instruments and whatever adapter you pick. So in this case, LabVIEW, it'll give you back basically a reference to that instrument. Also, it's a reference to that instrument in what state it was in. So if I look at this DMM, you can see I configured it to be set up to take a diode measurement, my ranges, my digits, yeah, kind of a lot of the things that you'd expect are on here. And if I wanted to make changes to that, I can actually relaunch Instrument Studio right from the step, make changes, save it, and it applies to the step. So it's not fully going the way of like some of the Express VI steps we had before, where you can set up a whole measurement. We're actually just for now we're stopping at the configuration side, and for you to actually take a measurement, you'll drop down a LabVIEW step, pass in the session of the instrument, and in this case, like for this DMM, all you really have to do is call initiate and fetch, and it'll give you back the same values that you're really getting in Instrument Studio. We didn't want to, at least at the initial release, provide out-of-the-box measurement steps because we're not going to be able to meet everybody's needs with that. So right now we stopped at, hey, here's the session configured as you set it up. Pass it into LabVIEW. If you wanted to do like, say, a multi-instrument measurement, like the scope and FGen one I was doing in Python, we wouldn't really be able to do that with just basic driver steps. But if you can pass both the instrument sessions into LabVIEW, drop down a few, synchronization steps to sync the two together and take a measurement, do some basic analysis, it really does help pull out a lot of the configuration information from your code itself into TestStand. The other thing I'll mention is the sweep loop we showed earlier. So this loop, if I drop it down, there is an option to sweep over sessions. So if I pick the scope, I can actually sweep over a number of the, they have to be attributes that we've defined as sweepable. It's not every attribute of a scope, for example, or every attribute of, an SMU. But most of the common things we think that people would want to change and sweep over, you support directly. So if I were to specify, scope's probably not the best example, but say a power supply, and I wanted to set voltage on a rail from 0 to 12 in certain increments, you can set that up in the sweep loop, and it'll actually apply it directly to the driver session. So you don't, in LabVIEW, you don't have to change the voltage range or the set point. TestStand will actually call a plugin that triggers the driver to do that for you. In your measurement step, you really still just have to have a, initiate fetch calls to the driver. So that's that feature. I'll pause for any questions you guys might have, and then I think I have 2 more slides, so I'm running up against time here, but I'll see if there are any questions.
So I have one. So how would you, on the PDF report generator, how would you configure the style of the report it's going to generate for you?
It'd be basically with whatever report you're using, right? So it'd be the same output as essentially this report. So whatever style sheet you're using, if you click generate PDF report, we're basically using like Chrome behind the scene to render it and generate a PDF out of it. Cool. Let's see. Let's move along. Package Builder. You guys may have already seen this. It is included with TestStand 2019 if you've downloaded it or installed it. It's also available separately. You can just get it. This is a new tool. Ultimately, we're going to use this to replace the TestStand deployment utility. That's kind of the long-term vision of it, at least for TestStand. But overall, the vision is more to be a package building utility that is product agnostic. So, I mean, the initial use case we're going after is kind of that TestStand deployment utility use case. But overall, there's nothing preventing you from installing like just VIs or the CVI executable on a couple of dependencies or really just arbitrary files. So this is the kind of the main differentiator here is that Package Builder was designed kind of from the ground up, from the idea that you're going to be building multiple packages that have a number of dependencies, not one monolithic package. So kind of this is more, I would say, a representative view of what we'd expect people to be doing. So if you look in the right-hand distributions tab, I've actually got 3 different packages. So like some common shared code that I'm probably going to use among a bunch of different projects. I have motherboard tests. It's a classic demo example you've probably seen, and then the actual some test VIs I'm going to call from that. So one of the benefits here is you can specify dependencies and constraints. So if I want to have a certain version of some common package, you can specify that, and then you can build a top level what we've been referring to as virtual packages, basically a package that doesn't really include anything but has a bunch of dependencies. So I can make a a test system config 1 package or a config 2 package that just reference a bunch of dependencies, and maybe there's one dependency change between them. If I install, say, package 1 on a PC, it'll sync and install all the dependencies it needs. And then if I go and install package 2 on the PC, it'll look at what's already installed and only install the extra package that you need. So this is really the direction that kind of package technology is going for NI. So right now, it doesn't do everything that the deployment utility does. There's still some stuff like registering .NET assemblies with a GAC, or some of the more specific TestStand features like packing loose VIs into a PPL for you. So things like that don't exist yet, but a lot of the more basic functionality does. So like if you specify a sequence here, it'll pick the dependencies for you. If you change their output directory, it'll actually relink them in TestStand for you. Make sure everything's compiled with the right relative paths and everything. So we're definitely moving towards the path of really kind of making the deployment utility unnecessary. But for right now, we're going to ship both of them. So this is actually an optional install if you want it or not, since it doesn't do everything the deployment utility does. But yeah, we're pretty quickly revving on this, and we're going to get it to really beyond parity. So ideally, a much better experience than what you get with the deployment utility today. That said, I'll mention that this is not. It's not going to be directly tied to TestStand releases. So we're going to be releasing Package Builder multiple times a year. So we're at least going to be ready to release every quarter. I mean, if we don't release every quarter, that's because there wasn't probably a significant difference. But internally, we're being very agile with this product. So expect to be able to go online by the end of the year, get a totally different version of Package Builder than installed with TestStand 2019. And then when the next TestStand version releases, we'll reference the newer version. The last thing I'll mention before I just open it up is SystemLink. So if you hadn't seen the test module, it was released last NI week. This is the initial release. And then this NI week was a pretty big step for a test module where we added in these tile-specific dashboards. So this is really just a way of aggregating kind of distributed test metrics. So pretty much everything you'd expect to show up in a TestStand report shows up in this, well, not this view, but in the test results view. You can see you can actually go and look through individual test steps and see historically how that step's done, things like that. You also get a nice overview, this customizable dashboard. You can make one-to-many dashboards. There's really way too many features for me to give it justice talking about. So if this is something that you guys are interested in, go check it out. I'll say it's got a lot of momentum at NI. SystemLink in general does. Test modules, particularly interesting one to me because of how kind of directly it integrates to TestStand. You really just install the client, you turn it on as a result processor, and you kind of get all this. So that's the end of the slides that I had. I wanted to open up to questions, and then I can talk briefly about some of the roadmap. I'm not going to get too into specifics since this is being broadcast to people that might have an NDA with us. but I can answer general questions. Any questions?
Again, to reiterate, this is also open to everyone who's joined us online. So if you've got a question, either post it in the oh yeah, we've got here one. So from Deepak Singh, does Python step type supports using multiple versions of Python?
Yeah, so you have to spin up a different interpreter for each different version. But yeah, so we support officially, we test and support with versions 3, 6, and 2.7, I think. But I've used newer versions and had basically no issue. Since we spin up Python in the default interpreter that you install, so we actually don't even install an interpreter. We rely on you to install it and put it in the path variable. Then TestStand will just launch it and marshal data back and forth from it. You can totally run one TestStand sequence that calls 2 different interpreters and runs Python code in 2 different versions of Python. That is something we support. We don't support running. I mean, you can't, like, it's not technically feasible to run like 2 different versions of Python in the same interpreter. It's just not how it would work. But yeah, you can run multiple versions of Python code from the same test sequence.
Thank you. So again, to reiterate, everyone online is welcome to contribute as well. So if you've got a question, just unmute yourself and ask your question.
We're going into a 15 minutes break, and so we'll get some coffee and then get back in the room. And we'll start quarter past the hour.
Yeah. So thank you very much, Trent.
Cool. Thanks, you guys. I might stick around for a little while, and then I'll have to hop off. But yeah, thanks for the time, and feel free to reach out if you guys have any other questions.
Thank you.
Thank you very much.